Welcome back to The Gig. I'm Johnny O, and this is for all things tech. Today I want to talk about storage. But first, before I talk about storage, I want to talk about the 4 technologies in computing that have changed our lives. Number 1 was the integration of a math processor into the CPU. The first iteration of this was Intel's DX2 486. Before that, you needed 2 CPUs. You needed your CPU, and if you wanted to run a CAD program or anything that was math intensive, you needed something called a math coprocessor. Now, the DX2 486 integrated that into the CPU. That was the first major stepping stone to where we are today. The second technology was the 3D effects processor, basically the first GPU. That's when we got the first 3D games. The first true 3D game, in my opinion, was Quake 2. It was all 3-dimensional, and it was processed. What you needed was something called a 3D effects card. Now, the 3D effects card, you needed a regular video card for Windows, but you need a second video card called a 3D effects card. That was the technology that you see today, and some CPUs have 3D effects built right into them now. The third technology was broadband internet. Now, I was lucky. I had a 3 meg connection in 1996 over cable. I was in a test area for where I lived. So I had broadband in 1996. Pretty much everybody else was on dial-up, 56K. And at the time, you would be very hard-pressed to even find a 56K dial-up service. So we were playing all these online games with massive pings. 100 was considered good. Anything under 100. 150, probably average. And if you were playing and it just so happened you had 40 or 50 ping, you were king of the internet, king of the game. Now, the third one is more recent, and that's SSD technology. So we had the math coprocessor integrated into the central CPU, number 1. Number 2, we had 3D effects processors. Number 3, broadband internet. And number 4, SSD, solid state drives. That's the technology you see today, and why your computers can boot up in 10 seconds and not 10 minutes, or a minute and a half, 2 minutes. SSD versus HDD technology. That's what I want to talk about today, storage. Now, SSD, there's 2 types of SSD. There's an M2 SSD, and there's basically an IDE, which runs over your USB bus SSD. Now, the M2 SSD runs on the PCIe bus, and that's why it's so fast. I have a computer at home, a laptop that boots in less than 10 seconds. And that's because it's on an M2 SSD. Now, because there's only a limited number of slots, the most, I think, on the market right now would be 3 M2 slots on a motherboard. So ideally, you would want as many M2 drives in your computer as possible to get it as fast as possible. For example, for Windows, just Windows alone, you want it booting off its own SSD, M2 SSD. Then for programs and applications, you want them running off their very own drive, like program drive. Just for programs, all your apps are loaded onto your programs. That would be on a separate M2 SSD. Now, with that configuration, your system would be zippy fast, very fast. Now, ideally, you would want 2 drives for Windows and 2 drives for your programs. This way, you could RAID them. And I've only heard of this once. It's only a rumor. I haven't seen any tests on it. But you can RAID 2 M2 SSD drives. And that would essentially, there's a small tax, double the performance. So Windows would be running on a RAID, an M2 RAID, booting up. So you're not booting in 10 seconds, you're booting in 5 seconds or 6 seconds over PCIe bus. Then your applications and programs would run on also an M2 SSD RAID, which means Outlook, Word, any kind of applications you're using, games even, would boot right away, would start up immediately. Then all your storage for your files, your pictures, your movies would be on SSDs, but they would be running over your USB bus. We used to call it the IDE bus, but they don't have that anymore. So you see these SSDs that are 4 terabytes, And 2 terabytes, those run on a different bus. They're not M2. M2 SSDs are very small. They're about the size of a stick of gum. It's essentially, you have the USB thumb drives. They take several of those chips and they essentially weld them together on a small daughter board and make it as small as possible, uses very little electricity, low power consumption, and they put it in a small slot, but it does run on your PCIe bus. The other ones run over your SATA. They call them SATA drives. Okay, it's essentially your USB bus, your internal USB bus, or SATA bus they might call it. And that's when you get the SATA cables, and these are much bigger than M2s. If you want an M2 that's 2 terabytes, it would be very expensive. I'm sure they come up to 1 terabyte, but that's an expensive drive. In fact, I have one in one of my laptops. 3 weeks ago, they introduced like a 2 terabyte M2. First I ever heard of it. Now, for the SSDs, you want a good size one, it would be 4 terabytes. 2 terabytes are okay, but you gotta think, these things are also, 25 times faster than a spinning hard drive, okay? Essentially what it is, all SSDs are just memory. They're memory drives. They work like memory, although they don't erase when you shut the power off. In fact, the data stays there for so long, it's almost considered permanent, unless you delete it, of course. Now, when a hard drive goes, a spinner, an HDD, fails, you can't get the data on it unless you send it to a special laboratory and they reset those platters and those read heads, which takes microscopes and a clean room in a vacuum, by the way. Not a simple process. I believe it's $2,000 or $3,000 per hour. And even then, they're not guaranteed to get all your data off there. With an SSD, even when it goes, all that means, when it's no good anymore, it just means you can't write to it. You can still read all that data, even after it's gone. You can read that data forever. Well, not forever, but I'm exaggerating, but the data's always there. It's like a natural backup. This is why they don't need tape backups and all this anymore, if your servers are running on SSDs. And even then, they take SSDs and they still sync them to an SSD backup. Pretty much that's it, you're done. There's no need for these tape backups or anything like that. HDDs are massive. They're 12 terabytes, 10 terabytes now, and then your high-end SSD, SATA SSD is 4 terabytes. In fact, you can get enterprise versions that are 10 and 40 terabytes, but you will never be able to afford them. They're way too expensive, and those are for big enterprise data centers. HDDs are just being phased out. I don't know where this technology is going to be, but it's just like the record player, but for computers. I mean, how many record players, even in the 80s, record players were on the way out. LPs, they called them. Same with HDs. I'm sure there's collectors of LPs and this sort of thing these days, and some of these old LPs are like old comic books, and you can collect them because they have really nice covers, and you can still play them. That won't happen with spinning HDDs, simply because once they're gone and once they're old, you can't use them anymore. They're useless. SSDs have taken over, and they've come down, down, down in price. This is where we get our performance, our really fast performances from our SSDs. We also get our redundancy built in, because even if the drive fails, you can still get the data off of it. Hypothetically, even if, say, there's some sort of fire or something, and the PCB board that chips in the SSD are on get burnt or damaged, it's much easier to take those chips off, put it on an identical board, and retrieve that data, as opposed to resetting the platters and the read heads on an HDD. So all around, the SSD is far superior. Also, the SSDs use a lot less power. And as the transistor count goes up in SSDs, they use less power because the transistor size or register size in SSDs goes down. They use less power, just like CPUs. Right now, CPUs are at 14 nanometer. I believe SSD technology, the register size is something like 19 nanometers. As that comes down to 14 nanometers, 9 nanometers, just like the CPUs, the register count goes up, the storage size goes up, and the electricity consumption goes down. So they're going to get bigger, they're going to get cheaper. If you have a laptop, they're going to be better on your batteries. The next thing you have to think about when you're considering SSD technology or storage technology is your file system. Now, file systems are the same, whether you're on an SSD or an HDD on Windows, you'll use the same file system on the SSD. It's organized a little differently. Now, if you're talking Linux or Unix, the old Unix systems, and even Mac OS X, and even the phones, Android and this sort of thing, that's a different file system. Now, the Windows file system is different. It's called NTFS. It's far superior, as far as I can see. In my opinion, it's superior to anything that Linux has. Linux does have some 64-bit file systems, but there's a lot of things that it doesn't have that NTFS can do. And I would say number one is it's compatible with Active Directory, and Linux is not. I believe you can read or write to a Linux, like a Linux or a Mac OS X operating system, but you can't read from it or something like this. I actually don't care because it's Mac. I don't like Mac. I think Mac is just Linux that's not open source. That's all it is. With NTFS, it's gotten better and better over the years. One thing I was disappointed about in Vista, they were supposed to introduce the new Windows 64-bit file system, and they didn't. They failed. That was actually my biggest disappointment. It wasn't just that Vista wasn't very good, it's just we never got the file system we wanted. Now, the reason being is the file system, 64-bit file system, compared to a 32-bit file system, is there's more usable space from a 32-bit file system to a 64-bit file system. You'll notice when you have an HDD or an SSD and it's 2 terabytes, I think you'll get 1.9 terabytes, right? I'm just guessing, this is hypothetical, but you won't get that full usable 2 terabytes. Now, some companies make the drives slightly over 2 terabytes, like 2.2, 2.1, so when you do install it, you get 2 terabytes. You'll find this with the high-end Samsungs and this sort of thing. You'll get the full 2 terabytes of storage. And that's only because they've made it slightly bigger to accommodate for that 32-bit file system. With the 64-bit file system, it uses more of that space. More of the space on the hard drive is actually usable. And that doesn't matter if it's an SSD or an HDD. One thing I am waiting for from Microsoft is our 64-bit file system. How the files are organized in an SSD on a machine level and how they're organized on an HDD are much different. So with an HDD, they are organized into sectors. Okay? Platters. Each platter has a sector, and that is burned in, basically burned in on the hardware level at the factory. They used to call it low-level formatting. An SSD stores the files much differently. It's stored in segments, and a file or a group of files, it'll fill up each segment first. If that gets full, then it will put more of the file onto the next segment. The problem is it has to be trimmed, because when you delete something, it doesn't actually delete it. It leaves it there and just says, okay, you can't use this. That's basically what happens. So there's a trim command. You don't have to defrag. It's called trim in an SSD. And what that does is once the files are deleted, it actually frees up that space for new files. You know, years ago it didn't do that, but it's gotten quite advanced, and there's even trim technology in Windows. It knows how to treat an SSD compared to an HDD. It used to be a problem. Like 6, 7 years ago, trimming used to be a problem. You used to have to do it manually with a manual command. Now it's done all automatically, and it works quite well. SSDs are just going to get better and better. So just to summarize, the 4 technologies that got us to where we are today in computing was integration of the math coprocessor into the central processor, called DX246 was the first processor to do this. The second thing was 3D effects processing. That's where we get our 3D games. The fourth thing was broadband. And I think that was widespread by early millennium, but I actually had it in 1996. So that's number 3, broadband. And number 4, finally, SSD technology. Now, don't forget to subscribe below. Subscriptions down below. Arguments down below. Questions, comments. I'll get to your questions. I'll get to your comments if I like them. If I don't, forget it. I'll just ignore you.